This is a Math 2 summary video for the lesson titled Curbside and Clementine. The purpose of this task is for students to solve systems of equations that involve a quadratic equation. Students will encounter problems in context and will use graphs, tables, and algebraic methods to solve. The lesson starts off by introducing the context. Clementine is an active and potentially mischievous dog. While Carlos is tossing paintbrushes to Clarita, Clementine, the dog, attempts to catch them in the air. The context gives us an equation that models the path of the paintbrush, which is a quadratic equation, and an equation for the path of Clementine. With these equations, t represents the time in seconds, and h of t represents the height above ground of the paintbrush and Clementine in feet. This question asks us to model the situation using a table and a graph. We can use the table and the graph to answer question 2, but before we do, let's take a close look at both the table and the graph that I generated with Desmos. In the graph, you can see a parabola in a straight line. The parabola represents the path of the paintbrush that Carlos is tossing to Clarita. The line is the path of the dog, Clementine. On our x-axis, we have time in seconds, and on the y-axis, it's labeled as the height in feet. In the table, the first column is a list of times. The second column gives us the heights of the paintbrush, and the third column lists the heights of Clementine. Question 2 is asking if Clementine will be able to catch the paintbrush. We can see from the graph and the table that there is a moment in time where Clementine and the paintbrush will be at the same height. On the graph, we look at the point where the two graphs cross. We can see that they actually cross in two different places, but in this context, we need positive times and positive heights. It would not make sense for Clementine to catch the paintbrush in the past underground. That point is not in our practical domain or practical range. On the table, we can see that the second and third columns both list the same height of 1.5 feet at 0.75 seconds. We can definitively conclude that at 0.75 seconds, Clementine will be at the same height off the ground as the paintbrush. Assuming that Clementine has good eye-snout coordination, it's very possible that she will be able to catch the paintbrush. We've already solved this problem with the graph and table, but let's take a look at how we would solve this algebraically. Since we want to know the time when the heights of Clementine and the paintbrush are the same, and the equations give us their heights, we can set the equations equal to each other. Now that we have a one-variable equation to solve, we have options for how to solve it. We could try factoring, completing the square, or use the quadratic formula. I'm going to use the quadratic formula. This means that I need to start by setting the equation equal to 0. Once the equation is set equal to 0, I'm going to write down my formula, identify the values of a, b, and c, and then substitute the values of a, b, and c into the quadratic formula. Now I just need to simplify. I'm going to start by simplifying what's under the square root and in the denominator. Then I'll split the equation so that one shows addition and in the numerator and the other shows subtraction. I'm going to continue to simplify and find that x equals 0.75 and negative 0.25. For this problem, there is only one answer that makes sense for the context. So we can again determine that at 0.75 seconds, Clementine and the paintbrush are at the same height. Now this problem does not ask us what the height is, but if we were curious to know how high Clementine will be above ground when she possibly catches the paintbrush, we just need to substitute 0.75 back into one of the two original equations. So to summarize, we have solved this system of equations using 3 different methods. We graph to find the point of intersection, we use the table to find equivalent values, and we use our skills for solving quadratic equations to solve this system algebraically. That's it for this video. Thank you for watching.